So let's do another related rates question. This time I've got a man and he is walking towards the wall, and we've got a big spotlight on the ground, and the spotlight's going to shine behind him, so he's going to create a shadow. Sorry, I cut off his head there, but the shadow is going to be this large here. So here's his shadow. Okay. And if he was just standing there, that would be the size of the shadow. Now what's happening is this guy is walking towards the wall. So the shadow size is going to change. And my question is, how fast is the length of his shadow decreasing when he is exactly 4 meters away from the wall? Okay, so it still seems a little bit of an artificial. You think, what do I need these for? But it's good practice to learn the techniques of related rates. So the first step is to set up some variables here and some fixed values. You're going to need to know the height of the man. Okay, so we're going to put that in, and he's fixed, so I can actually put that value in right now. He's 2 meters tall. And this, you're going to also need to know the distance the spotlight is away from the wall, and that is 12 meters. So we know this is 12 meters. And notice I'm putting those values in. But there's a lot of things that are changing with this question. We know that the distance, he's walking away from the spotlight, so this distance right here between him and the spotlight is changing. And so notice I've got a variable there. Also, the height of his shadow will change as well. So I'm going to put that as y. The height of his shadow is changing. And there is another distance here that's changing, and it's the distance between the wall and the man. And instead of introducing another variable, so I'm talking about this distance right here is changing, but instead of introducing a new variable, I'm going to label this as 12 minus x, because it is 12 minus the distance he's already walked. So that reduces my variables to be just 2, x and y, instead of a third one. So I'm going to now, that was my step 1, to make a diagram and label the variables that are fixed, the variables that are changing, and the values that are fixed. Second step is to establish a relationship between these two. And you might think Pythagoras, because we've got a right angle triangle, but that would be introducing a third variable, which is the hypotenuse, and I really don't want to do that. So there is another relationship that works, and that is the relationship between similar triangles. So we've got a similar triangle happening right here. I'll do it in highlight here. There's one. Is very similar, or it's similar, not very similar, similar to this green one, because the angles are all the same. So that means I can establish the ratio of sides. And if I do that, then I know that y is to 12 what just lost my train of thought here. Y is to 12 as 2 is to x. So I'm comparing 2 and y. So those are the two numerators. And sorry, I got that one wrong with all my flipping back and forth here. This should be 12. And y is to 12, sorry, got that. 12 compared to x. So those two compare. Sorry about that. So here I've got my relationship, and I am going to have to take the derivative of this. But before I do that, I want to interpret the information that I've been given in terms of calculus notation. So I need to be told what speed the man is moving at, which means that this variable is changing dx by dt at a rate of 1.6 meters per second. And my question is, how fast is dy by dt changing? That's my ultimate goal. And I want to find that out when the man is 4 meters from the building. So if he's 4 meters from the building, that means x is 8 at that point. All right, so now I've got to take the derivative, and I'm going to insert a new page here to do that. So my relationship is x over 12 equals, y over 12 equals 2 over x. And I'm going to, I think, get y all by itself here. So it's 24 over x, just multiply both sides by 12, and then I'm going to take the derivative. So dy with respect to time, because we're talking about how fast things are changing. So if I change this to 24x to the negative 1, it would be negative 24x to the negative 2 times by dx by dt. So rewriting that, I've got dy by dt equals negative 24 over x squared divided times dx by dt. And I'm told that I want to figure this out when x was 8, when he was 8 meters from the wall. And I'm also told that dx by dt was 1.6 meters. And that means that I'm going to plug these two values into my equation. So dy by dt equals negative 24 over 8 squared times dx by dt, which is 1.6. And working that out, you should get approximately negative 0.6 meters per second. Meters per second because y is measured in meters and time is measured in seconds. And why the negative? Does that make sense? So let's go back to our last picture and say, why does that make sense? As he moves closer, let's say he's here, the light is now going to shine down here, and our shadow is getting smaller. So that's why the negative